Continuing with our discussion of compound events, we looked at independent events, and here's the definition of the day. It's really complicated. Two or more events are dependent if they're not independent. No kidding. Dependent events are ones where the occurrence of one of them does affect the occurrence of the other. So if A and B are dependent events, then the probability of A happening, then B happening, is the probability of A times the probability of B given that A has occurred. And another way of saying this, and we'll see this notation again much later in the chapter, probability of B given A. This vertical line in probability notation means that the thing after it has already happened. We're assuming that A has happened here. So we have a box with buttons in it. Blue ones and yellow ones. Goody, goody. We're going to pick two buttons out of this box without replacing them. Very important thing here. Without replacement. What that means is that our events, the first pick and second pick, the first button and second button, are dependent events. So we have to be thinking about this, that the probability is going to change for the second pick. So for part A, probability of yellow and yellow. Okay, what's the probability of picking a yellow? Well, it's 3 out of 7. Times, now let me back up. Let's get some probability notation. So this will be probability of yellow times the probability of a yellow given that a yellow has already been picked. So what's the probability of picking a yellow? Just said it, it's 3 out of 7. But now what's the probability of a yellow given that we already picked one? So now, how many buttons are there in the box? There's only 6. And how many of those buttons are yellow? This just means think about what has changed. So now there's only 2 yellows in that box. So our probability becomes 6 out of 42, which is 1/7. And again, yes, you do have to reduce, ladies and gentlemen. Second example, probability of yellow, then blue. So this is going to be probability of yellow times the probability of blue given that yellow has occurred. So probability of yellow, again, 3/7, times, now what has changed? This whole makeup in the box has changed. There's only 6 buttons to choose from. And of those 6, how many are blue? How many are what we want? There are 4. So 3/7 times 4/6. I'm going to go ahead and reduce this before I multiply. 3 goes into 3 once. 3 goes into 6 twice. 4 over 2. 2 goes into 2 once. 2 goes into 4 twice. This probability is 1 times 2, or 2. 7 times 1, or 7. So 2/7. 2/7 of the time, when we pick 2 buttons, the first one would be yellow, and the second one would be blue. So again, this notation, this fact that one thing has already happened, just means you have to think about what has changed.